This is a global winds presentation by Ricky Lee. So one of the topics that I had was the Intertropical Convergence Zone. The Intertropical Convergence Zone, also known as ITCZ, is the latitude of Earth that receives the most intense sunlight. This area is typified by dense clouds and precipitations because as warm and humid air rises at this latitude, precipitation falls as the warm air experiences adiabatic cooling, which causes water vapor to condense into rain and fall back to Earth. The latitude of the ITCZ also shifts between 23.5 degrees north and 23.5 degrees south, since the axis of Earth's rotation is tilted. And also due to that, the tropics will experience seasons of high and low precipitation due to the shifting of the ITCZ. And in addition to that, we know that biomes such as the desert will be located near the equator because since that is where the ITCZ is, where it will receive the most intense sunlight, and biomes such as the tundra with cold temperatures will be located further away, as you can see on this map right here. So doldrums. The doldrums are basically the same thing as the ITCZ. It is also where doldrum is also where the prevailing winds of the northern hemisphere blow to the southwest and collide with the southern hemisphere's driving northeast wind. They're called doldrums by sailors for a reason, because due to intense solar heating at the ITCZ, moist air rises in the atmosphere, and because the air circulates in an upward direction, there are little surface winds at the doldrum, which means the area can be very calm for sailing ships for weeks, and that is why the sailors call them doldrums. So the Tropic of Cancer. The Tropic of Cancer, also referred to as the Northern Tropic, lies approximately 23.5 degree north latitude of the equator, and it runs through Mexico, Bahamas, Egypt, Saudi Arabia, and others. And the subsolar point, which is the point on Earth where sun hits at 90 degrees at Earth's surface, is at the Tropic of Cancer during the June solstice, and when the northern hemisphere receives the most solar insolation. And similarly, the Tropics of Capricorn lies approximately 23 degrees south latitude of the equator, and it runs through Australia, Chile, southern Brazil, and northern South Africa. And at the winter solstice in the northern hemisphere, the subsolar point is directly at the Tropic of Capricorn, which is when the southern hemisphere receives the most solar insolation. And now let's examine how high and low pressures within the Hadley cell affect the air. As air rises higher in the atmosphere, the pressure on it decreases, which allows the air to expand in volume and thus making it colder. And since cold air is dense, it will sink. And the cooling effect of this is known as adiabatic cooling. And similarly, as air sinks lower in the atmosphere, the pressure on it increases, which makes the air hot and rises again. And this process is known as adiabatic heating. And this concludes my presentation.